Hi, my name is Har'el Rosen. I'm a physician with On-Site Neonatal Partners, and I'm here to present to you a problem which is common in newborn infants, and that's newborn jaundice. A neonatologist is a physician who cares for sick or premature newborn infants, and unlike adults, the problems faced by newborn infants are unique. They're not just small adults, they have a unique set of problems. And the problems which we address in newborn infants are very often technology dependent for their solutions. I'll start off by discussing a little bit about jaundice. Jaundice is a yellowing of the skin, which is due to a buildup in the blood of a substance called bilirubin. Now, where does this yellow substance, this bilirubin, come from? Well, it's part of the process of metabolism of red blood cells. When red blood cells break down, there's a chemical process which begins with a molecule called hemoglobin. Hemoglobin is the molecule which carries oxygen. It picks up oxygen in the lungs and is transported in these little red blood cells to the various cells of the body which are using the oxygen. Hemoglobin is what gives blood its red color when it's carrying oxygen. And as hemoglobin breaks down, through a series of steps, it's converted into a substance called bilirubin, which is a yellow-orange color. Now, our bodies are constantly producing new cells as the old ones are breaking down, so this is an ongoing process. And this bilirubin has to be cleared somehow as a waste product. Where does this bilirubin get cleared? Well, the liver, which is an organ right under the left side of the rib cage, has a number of functions, but one of its functions is to act as a filter. It clears out waste products and dumps them into the intestines, where we dump our waste products. The liver is responsible for another number of steps which change the structure of bilirubin to make it more water-soluble. By making it easier to dissolve in water, the body can clear it more readily. Now, newborns are by nature immature. And immature just doesn't mean that they can't do a lot of stuff, but that they can't do things well. And the liver, as an immature organ, is not as good at clearing bilirubin as liver in an older child or an adult might be. And the bilirubin tends to accumulate in the bloodstream. Now, in most cases, this elevation in bilirubin is mild. So the baby looks a little bit yellow, but there's no consequences to that jaundice, and after about 5 to 7 days the jaundice goes away on its own and there's no issue. However, at high levels, bilirubin is a very potent toxin, and the main issue is that bilirubin can cross from the bloodstream into the brain and poison the brain to the point where it can cause permanent brain injury and even death. So our job as physicians, the goal of medical intervention is to curtail, to slow this process of bilirubin elevation if it is occurring too quickly and has a potential to cause harm to the infant. Now, how many babies get, how common is jaundice? Well, jaundice in general is very common. About half of newborns will get jaundice to some degree, but only about 10% of those will actually need intervention to prevent problems. So the question then becomes, what can we do to curtail this rise in bilirubin? And the current state of the art dates back to 1958. In 1958, a physician by the name of Kremer is credited with noticing that babies in the nursery who are kept closer to the windows tend to be less jaundiced than those who are in the interior of the room. And this was really a eureka moment. Sunlight somehow reduces the risk for jaundice in newborn infants. Now, even before they understood all the mechanisms, the work was on to try and mimic sunlight and see if artificial light can also result in decreases in bilirubin levels, and it turns out that this does work well. Systems which are most commonly used today fall into three general categories. The first category uses regular lights, either fluorescent lights, full spectrum fluorescent lights, or halogen, full spectrum halogen bulbs to shine light on the infants. But what exactly is happening when light shines on the babies? Well, bilirubin, as I mentioned, is a yellow-orange color. We see it as yellow or orange because it is reflecting light in the yellow to red area of the spectrum. Whatever light is not reflected is being absorbed by the molecule so that we don't see it. And what's left is blue light. Bilirubin specifically absorbs blue light. And the magic is that when bilirubin absorbs intense blue light, the molecule actually twists. And when it twists, it becomes easier to dissolve in water. Now, once this molecule is water soluble, it no longer depends on the liver to make that conversion. So it can be excreted directly into the intestines. It can be excreted by the kidneys into the urine. So what we do is we bypass that immature, slow enzyme process in the newborn liver and help the baby clear bilirubin. The duration of the therapy is dependent upon how long the baby's liver takes to gear up its enzymatic mechanisms and how long it takes the baby to slow its bilirubin production. The rise in bilirubin is based on two components: production and clearance. The newborn baby is actually born with a lot of extra hemoglobin, a lot of extra red blood cells on board, because before it was born, it was literally stealing oxygen from its mother. So in order to maintain normal oxygen levels, the baby's hemoglobin levels, the red blood cell levels, are higher than they would be for you or I. After the baby's born, it's in an oxygen-rich environment, and it starts to clear out these excess red blood cells and generates bilirubin in the process. So you have more red blood cells than normal and a slower liver than normal, and both of these factors contribute to the rise in bilirubin. Now, how quickly does this resolve? Usually within a week. So the peak in bilirubin production is somewhere around 3 to 5 days for a full-term infant. It may stretch out to a week, rarely up to 10 days for a baby who's born very premature. Almost always is resolved one way or another by the time the baby is 2 weeks of age. The key is that many babies will need help to get past that initial problem. There are also a number of other medical problems, disorders, diseases, which can contribute to either decreased clearance, liver problems, or increased bilirubin production, a number of different blood disorders which can lead to increased bilirubin production. Bilirubin tends to be a molecule which is soluble in the tissues, so it will get deposited in the skin, but it will also get generally distributed through the body, and the brain is the organ that we worry about the most, because in the brain, bilirubin can be very toxic. What is strong enough? And the answer is that we don't really know what strong enough ends up being. The medical criteria for effective phototherapy are based upon the technology which was available when those guidelines were produced. So we know that the brighter the light, the more effective the phototherapy is. But up till now, we've been limited technologically by how much blue light a halogen bulb or a fluorescent bulb can generate.